Good morning, and welcome to Make the Web Faster. Today we're going to bring you 3 new technologies. My name is Joshua Marantz, and I'm going to talk about Mod Pagespeed, which is an Apache module which automatically rewrites web pages to make them display faster. Richard Rabbat will talk about WebP, which is a new image format for the web, and Wium will talk about Opera and WebP. So why make your website fast? The benefits are many. Among them are user satisfaction. People like to go to fast websites, better engagement, and more revenue. But it's hard. The techniques for improving websites are reasonably well known, but they're cumbersome to implement manually. There's trade-offs to make. There's the trade-off of maintainability, of being able to easily change your website and maintain it, versus keeping minified versions and sprites of your images and your text, etc. There's an agility trade-off because if you set your cache lifetimes for a long time out, it's very difficult to change your JavaScript to fix bugs and have it push out because users' browsers have cached in it an old version. And if you set the cache lifetime short, you get agility, but then everybody, after they come back to your site, if they come back on a daily basis, they'll get a fresh download each time. So another aspect is that browsers are moving forward at a rapid pace. New browsers have new techniques that can help web developers build faster websites, but the old browsers lack these techniques. And you don't want to leave all the users who are stuck on old browsers for various reasons behind. You want to continue to support them while letting new browsers exploit the techniques. So you kind of have to have some server-side intelligence. And we're discovering new techniques all the time. There's a talk later today about mobile best practices, and as these techniques are learned and adopted and changed, you want to be able to have a tool that helps adopt your website rather than employing somebody full-time to keep up with these techniques and adjust your website accordingly. So the solution is to use automated tools. So this is what Mod Pagespeed is for. Optimize your website without having to change it. You don't have to change the way you generate content. You don't have to minify your CSS and your JavaScript by hand and keep 2 versions around, spriting your images, etc. You don't have to manually run image magic over your whole library of photos and keep 2 versions of those. Get a machine to do that for you. That's what machines are good at. So what does Mod Pagespeed do? It actually does no black magic. The techniques for optimizing web pages, there's basically 2 Bibles written by Steve Souders, high-performance websites and even faster websites, and they are pretty much the techniques that we use today in Mod Pagespeed to make your website faster. Image compression, sizing images to the right size, minifying CSS, JavaScript, and HTML. We take small images that are below a certain threshold and inline them, same with CSS and JavaScript. And probably most importantly, we extend cache lifetimes, and we'll talk more about that. All of these techniques are listed. We have a demo site called modpagespeed.com. You go to that site. It shows you every optimization that we do, documentation before and after. So here's one example we'll dive into called combining CSS files. So if you have 4 small CSS files, each one of these, when it's rendered in a browser, would represent a separate HTTP request. For all kinds of reasons, it's better to bundle these into one file. And this is not very hard to do by hand, but it's kind of hard to maintain over time, and it's kind of a conflict. So to get a tool to do that for you, you turn on Mod Pagespeed, and that one line, those 4 lines of links become one link with the concatenated name. And one of the most important things we do is we add to the concatenated name a hashtag, which is the MD5 sum of the content of the file. And by doing this, that enables us to serve this resource, the combined CSS file, with a very long cache lifetime. This means that browsers will retain knowledge about this file. We set the cache lifetime for a year. But if you want to go back and change one of these CSS files that it's built out of, then Mod Pagespeed will pick up that change, will recompute the MD5 tag, will serve the rewritten CSS link with a new name, and the old stale entry in the browser cache doesn't hurt you. So you kind of get the best of both worlds, which is a long cache lifetime, but an easily changeable site. So how do you bring mod PageSpeed into your web serving flow? You have an existing Apache HTTP server. You can download from code.google.com our source code and compile it, or we have pre-built binaries for CentOS and Debian and Ubuntu. And so you pretty much download into the Apache server, and now you don't have to change your content. You don't have to change your content generation flow. You may want to tweak some of the settings in pagespeed.conf. That's optional. And you get out of that reduced latency, improved bandwidth, and much longer cache lifetimes. So taking a peek under the hood, mod PageSpeed is really divided into two sections. There's a platform-independent rewriting infrastructure. And it has a whole bunch of pieces in it, but it's all called PageSpeed Automatic. And this is the engine that rewrites web pages on the fly. And on the right, we have a bunch of plugins which are used to adapt this architecture to a specific platform. And the first deployment for this technology is an Apache module. So we have an Apache module, Gasket, and this defines mechanisms for caching HTTP content, caching metadata, fetching resources, threading, and other assorted tasks. It's kind of a plug-in architecture so that this can be applied to multiple platforms. But our deployment initially is Apache HTTPD. So how much faster has this made the web? So far, this has been launched for about 6 months. We launched in November of last year. A few days after that, DreamHost, a hosting provider, made it a push button on their control panel. So any DreamHost hosted site can push a button, and mod PageSpeed is activated on their site. A couple of months later, we announced with GoDaddy, the dominant hosting provider, who has a similar push button flow. It's actually a config file change, but any GoDaddy user can enable mod PageSpeed with basically a line in a config file. The project is built on a large base of source code, including the PageSpeed source code and a lot of Chromium source code, but we have about 60,000 lines of code that we wrote ourselves for this. So it's a significant project. About 54,000 sites have installed and are running mod PageSpeed as of today, and the number is climbing. So what does mod PageSpeed do to the sites? Well, let's take a look at 28 sites that we looked at that have installed mod PageSpeed. So to test the sites, we used a tool called Webpagetest.org. Webpagetest.org is a client-side testing technology. It's kind of built in with various browsers. In our case, the browser that we used was IE8. So these are all IE8-based numbers. And the blue lines indicate the first view, the first time a page is brought up. And the red lines indicate the repeat view. So that's with a warm cache. And every website is different. We find that a typical improvement between 20 and 30% is not surprising. We've seen improvements as much as 50%. And this is basically just by downloading a module and turning it on. There are websites that have already been hand-tuned to follow all the best practices, basically do the same things manually that mod PageSpeed does automatically. And in that case, we don't offer much improvement. In fact, we add some overhead because we have to go and parse the website and say, nope, this is all done. So let's look at this data from a different perspective. Let's look at the images on the top 1,000 websites on the web, the Alexa 1000. On these images, there are, of this corpus of images, a fairly significant number of them, mod PageSpeed just looked at them and said, I can get rid of a huge percentage of the bytes, over 75% of the bytes. This would typically happen if somebody takes a photograph from a camera and puts it into a thumbnail on a web page. Most of those pixels are not going to be seen by the user, so why do you want to ship them over the wire all the time? Get a machine to reduce that for you. You don't have to manage that with compressing it with ImageMagick yourself. You just let mod PageSpeed do it. But a really surprisingly high number of images can be improved by a significant amount, say 20 to 25%. And these typically come from just better compression ratios or re-encoding color maps to be more optimal. or getting rid of all of the metadata, the f-stop at which the photograph was taken, et cetera. So let's dive into one of the sites that has installed Mod Pagespeed called androidacademy.com. First of all, we know that it has installed Mod Pagespeed because when we look at the HTTP response headers from that site, one of them, the one where the gray arrow is pointing, it says x-mod-pagespeed. So we know that that site was rewritten by Mod Pagespeed. So we tested this site with webpagetest.org, which produces a lot of data. It also produces videos. So on the left, Mod Pagespeed is off. On the right, Mod Pagespeed is on. So this is a download and go. In this case, the site is sped up noticeably by turning Mod Pagespeed on. But let's go back and look at the numbers. So here's some colored bars. The top colored bars represent the first view, the off on the top and on the below, and below that you see the repeat view. So the first bar, the blue bar, represents the time to first byte. That's the time between when the browser sent the request for the HTML file and the first byte of HTML that came back. And you'll notice that when we turn Mod Pagespeed on, we actually make that take a little bit longer. And that's because we've introduced this server, this rewriting pipeline into the flow. So we've actually added some processing. Typically 10 to 30 milliseconds of delay is added to that first byte. But we find so much on most websites to improve that by the time you get to the time to first paint, we've benefited the site by close to a second. By the time you get to the page load time, the onload handler, we've benefited the site by more than 2 seconds on the first view. And on repeat views, the numbers are a little bit different, but and the reasons for the improvement are also different, and we'll go into those. So these are the waterfall diagrams for this site, androidacademy.com, that have been collected and rendered by webpagetest.org. On the left, Mod Pagespeed is off. On the right, Mod Pagespeed is on. The top ones are first view, and the bottom ones are repeat view. And each of these things, you don't have to zoom very far into these things and look at all the data to understand the story. On the first view, you'll notice that the waterfall diagram is significantly shorter. It's probably about 30% shorter with Mod Pagespeed on, and that's because of two things. It's because of inlining small resources, so there's less HTTP requests, and it's because of combining resources, so combining multiple CSS files into one, et cetera. On the bottom, we have the repeat view. Oh, I should say that the first view also benefits because we compress images, so we make the images smaller, but it's harder to tell that by looking at kind of a zoomed out view of the web page. You'd have to look at the waterfall diagram in a lot more detail to see that. But we'll take a look in more detail at an example where we can show that later. So the bottom charts with the big yellow blobs, those are the repeat view. And what those yellow bars mean is that's called a 304. That's where the browser has a copy of the resource, an image or a CSS file, but it doesn't know because it doesn't have a long caching lifetime or the cache is expired, is this valid or not? So it has to send a request to the server saying, hey, I've got this resource that's got this hex tag called an E tag. Is this one good? And in this case, during these tests, it is good. So the server sends back, yes, that's good, go with that. And that's a very low bandwidth request, but it incurs a complete round trip time. So with Mod Pagespeed off, you have to do a lot of round trips to the server, even with a warm cache, just to make sure that all these resources are still valid. Because we've done cache extension and added those hash tags, those MD5 sums to every URL, the browser, if it has the URL, it's the correct URL because the content hash is in the URL. So that's why the repeat view waterfall diagram with Mod Pagespeed on looks a lot more compelling. So let's take a look at how we do our measurement. With webpagetest.org, we kind of did 4 runs which is mod PageSpeed on and off with repeat view and first view, and then we repeat that 50 times. And the reason that we repeat that 50 times is that measurement on the web is hard. If you were to get a stopwatch and hit the refresh button in your browser a whole bunch of times and just write down all the numbers, you'd see that there's a fair amount of variance. It's kind of hard to do this. It's a lot easier for a machine to do this, but still, there's a lot of things in between the client and the server that can cause variance. It's a measurement variance. One of those things is the network. In this case, Android Academy is hosted out of England, and our testing clients were located in the US, so we had an intercontinental delay, which probably added a fair amount of variance to our tests. And I think that's probably what accounts for most of the jitter, but we have also seen with many other sites where the servers are overloaded, and we think that, and you'll see that the red and blue dots are much more of a jumble, and it's hard. If you were to just do like 1 repeat or 3 repeats or something like that, you could easily draw the wrong conclusion, and you have to kind of see a lot of data for us to be able to get confident. So in this case, while there's a fair amount of jitter, the improvement is pretty clear. There's jitter in the measurement, but the results are quite clear that mod PageSpeed has consistently benefited this site. So where are we going with mod PageSpeed down the road? We are installed on around 60,000 servers. That's a start, but we'd like to make the whole web faster and not just 60,000 sites. So we're seeking leverage ways to do that, high-volume partners, hosting providers, CDNs. We'd like to encourage leverage integrations with servers, proxies, and caches that could put this technology in line. Like we saw on the architecture slide earlier, it's kind of a plug-in architecture, so it should be feasible to integrate this rewriting technology into other stacks other than the Apache stack. And we've just been going all out trying to support every user that uses mod PageSpeed. You can see us on Twitter, you can see us on our discussions list, et cetera, trying to get everybody successful that's trying to use it. We'd also like to make the web more fast. We've been going through the basic optimizations that are recommended in the Souders books that I showed before, but we're working on things like image spriting and WebP integration. We're going to talk about WebP in the next segment of the talk. We'd like to add deferring JavaScript execution. There's a whole suite of things that we are anxious and excited to start working on to make the speed-ups more dramatic than what we have so far. It's also important to put effort into measurement. We want to measure better. Like, we have dozens of filters now that help rewrite web pages. Which of these have the most impact? We'd like to get some data behind that. And we'd like to help users evaluate mod PageSpeed, the benefits from mod PageSpeed. The more you're kind of hitting refresh with a stopwatch, the more hard it's going to be to draw repeatable conclusions from. We want to enable users to effectively gauge the benefit they're getting from mod PageSpeed. I want to jump out of the presentation. Let's see how this looks, and show you more image stuff. So this is an example you can do yourself. This is off of modpagespeed.com. This is the site I showed a snapshot of earlier. This shows you all of the rewrite passes that mod PageSpeed supports. I went into the rewrite images example. This is the before picture, where we have 3 images. And this is the source code, the view source. It's probably not that visible, but this gets rewritten. So there's a couple of key points here. Puzzle.jpg is about 235 kilobytes. We don't really need all those bits. We've displayed it in a small space. Why not have the rewritten puzzle.jpg, which is put into a 256 by 192 thumbnail, which we can serve you in 21 kilobytes, and can you tell the difference? In addition to that, besides making that JPEG a lot smaller than when you pulled it out of the camera, one of these images is sufficiently small. I think it's the this coffee cup. is sufficiently small that we've decided that it's better to inline it. So on the after page with Mod Pagespeed on, you see one less line in the waterfall diagram. And that's because that coffee cup has been rendered as a data URL so that it can be displayed without having any additional HTTP requests. Okay, so Mod Pagespeed. It's a technology, it's an open source Apache module. It uses an Apache license, which means you can basically download the code and do whatever you like with it. So it's an open source Apache module, which automatically makes your websites faster. There's two key points here. One is that it makes your websites faster by doing these rewrites for fairly well-known techniques. And the other one is that it's automatic. Even if you know these techniques, you might decide that you don't want to maintain keep doing them yourself manually every time you change your site. So there's all kinds of material on the web about this. It's easy to search for it now. The first place to go is modpagespeed.com, which shows all of the places, all of the rewrites that we do before and after. So next up, we have Richard Rabbat, who will talk about WebP.
Thank you. So before I start talking about WebP, I want to mention that when Josh and I started this project, people were telling us that we were crazy, that we had this developer tool, Pagespeed, that we've been innovating with, adding lots of new best practices and trying to understand how people can make their pages faster. And then at some point, we decided that we should make this automatic. We decided that we could try to spend a lot of engineering time to make the web developer not spend time themselves optimizing their pages, but instead focusing on their content and adding delightful content for your users. And at Google, it's kind of nice because they let you try and fail, and sometimes if you fail too many times, they don't let you try anymore. But it was just amazing when we launched this. Like the uptake was, we were actually not expecting that people really wanted this technology in that fashion, and we were very surprised. And it just helped the engineering team, put in more effort. People put in, weekends, weeknights, and things like that. One thing that Josh mentioned, which is we've been doing a lot of measurements with things like webpagetest.org, and it's a great tool because you can see what's happening. But last week, if you have Google Analytics on your website, the Google Analytics team launched a site speed measurement tool, which allows you to see the exact latency that your users actually experience, as opposed to when you're under a controlled environment from a certain server or from close to your server. So if you use Google Analytics, you should definitely add one line of code and see what your users are experiencing in terms of latency. It may be very eye-opening for you. So talking about WebP, WebP is one of these other examples of crazy ideas that we try and we see if it's going to work. And let's see. And as you all know, most of the images out there are in JPEG format. This is one of the Google logos at some point. So JPEG is a lossy format. GIF, GIF has been there for a very long time. It has very specific use cases that people still want to have. There's the tracking pixels, which we don't like to talk about, but there's also things like transparency and animation. GIF is great at allowing you to do transparency, but also people like small animations. 2, 3 images next to each other. Ping has been used, portable network graphics has been used for very high quality icons, text, graphs, things like this. This is an example of a ping, Google I/O. You want to see developer conference. You want to be able to read the words developer conference. But if you look at the web, at web pages, we all know that an image is worth 1,000 words. And today on the web, there's a lot of bytes that are totally like image bytes. And you can look at this is data from httparchive.org. And the HTML bytes that you're shipping to your users are in the tens of kilobytes, and images are in the 400 kilobytes. There's this data from Intel Corporation that says that compression hasn't changed over the past few years, but there's a lot of CPU power that people have on their devices. Some of you may have gotten some tab devices today. Great technology. The processing technology in these tablets are way more advanced than what you got in a supercomputer 10 years ago. And there's a lot of algorithmic improvements. So we decided to try to figure out if we can change if we can propose an image format that can lead to better compression than what JPEG does. It is based on the VP8 bitstream, which is what's also used for the WebM video format. And at first, we did a pretty large study with about 900,000 JPEGs. And if we took them and we tried to compress them again for the same signal-to-noise ratio, we would get about 39.8% better compression. And we thought, oh, maybe it's just because the JPEGs that are out there are just full of extra bytes that are not really needed. And basically we did something we call re-JPEG, JPEG recompression. And we could only get 14% improvement over that. Recently, we started a new study, which is based on SSIM, which is considered a better metric for image quality. And we took about 26,000 pings. And we did a compression at JPEG quality of 75. We recompressed for the equivalent SSIM quality. We were getting about 40% smaller. Towards the end of this week or next week, we're going to release a much larger study with some of the images that people are used to looking at when they look at image compression. Now, why is WebP so cool? If you look at low bitrate performance, this is an image that one of our friends from Wikipedia, Matthias Schindler, tried. He took a picture of one of the German senators and tried to compress at very low bitrate in WebP and JPEG. And you can see at low bitrate, the JPEG just doesn't quite get it. And at high bitrate, WebP provides you something that's just as good as a lossless compression like ping. And why do we do WebP? This is data from, again, webpagetest.org. We have this website where we're comparing a bunch of images that we put in JPEG versus a bunch of images that we put in WebP. And you can see that some of the data, for example, the fully loaded data, shows that for WebP, you can save about 3 seconds in time for fully loaded because you're downloading many less bytes. In this case, we're downloading 529 kilobytes versus 729 kilobytes. And it directly impacts the speed of your web page loading. So WebP, we started with WebP, and we focused on speed because that was going to be the major feature of the format. But we also wanted to delight a lot of our users. So when we first released it, people gave us some good feedback that they wanted to see a better encoding of the image. And we spent a few months. We improved the encoder itself to focus specifically on still images. the WebM encoder was very focused on the transitions, the video stuff. Instead, with WebP, we focus our encoding on the still image, and the feedback is it's now beating JPEG much more readily. So what are we doing next? A bunch of new features. So we want to support people's need for metadata, and we're adding XMP support. XMP is Extensible Metadata Platform. We know some people are used to EXIF, but EXIF has been painful for lots of people as well, because it just there's no real standard around it, and it just creates problems for the web. So because this is a format that we want to have for many years in the future, we're focusing on better, cleaner technology. Animation. So we said when we first launched WebP, we had a lot of comments. We want animation. And we said, well, just use the video tag. It's great. And they're like, no. So we tried to figure out exactly why. And it turns out it's mostly a philosophical issue as opposed to a technology issue. People that like to do development of animated images really want to use their typical, the typical software that they're used to, like their Photoshop, their ImageMagick. They don't want to use FFmpeg for creating an animation. So we're adding this, and because we're now in a much newer world, we're adding 3D stereoscopy. Tiling, because you can have in a bunch of images, you can create as large of an image as you'd like, and it gives it, you can start displaying parts of the image as you can download it. And there's one real cool thing that we're adding. Who knows about CSS background images? Okay. Who likes how they have to write them? Okay, thank you. So if you look at the third column, what we're doing, sorry for the colors a little bit here. So we're basically grouping images together, and they're going to have a hashtag. And image source, for example, group.webp, hash John, and hash Jack. And then instead of having to figure out exactly what coordinates you're going to pick the image from, you can actually just refer to the image within that multi-image format. And there won't be any weird CSS to write. For 3D, again, if you look at the third column, if you look at 3D images that are out there that are in JPEG, if you display them on a 2D display, they just don't make any sense. So with our ability to put multiple images in the same image file, we can actually call the left image versus the right image separately, and then we can show them. It depends on what display technology one is using, and then you can see you can maybe downgrade to a 2D for some people, present 3D for others, and also use it depends on the capabilities of the device. But it's definitely an image format that we're looking at to grow in the future. So it's still young, and we're adding some more things. Last week, one of the engineers added a JNI interface, which we think is cool. And we're adding lossless so that we can have better transparency support. On the product side, Picasa, Web Albums, Gmail, and Google App Engine are adding support. Picasa Web Albums already has it, as well as Gmail. Google App Engine is going to have that support soon. And what you get with WebP is when you have VP8 hardware support, you get WebP hardware support immediately. The next release will also have a much faster codec. Now that we have a very good encoder, we're spending some time writing assembly code to make it much faster. And that's it. And at this point, I'd like to welcome Hukum to talk about Opera and WebP. Thank you.
Perfect. Thank you. Thank you, Richard. Thanks for inviting me here. I was at Google I/O last year as well when the video format WebM was introduced. And this is a pleasant follow-up, I think, to be able to do a still image format. I had to make one comment, though, but you talk about the weird CSS syntax. I'm partially to blame for that. I proposed CSS in 1994. And my baby, it's kind of grown since then. And I agree with you that the background, the multiple background images, is kind of weird. But it's also stuff that we don't really encourage people to use. You shouldn't really have multiple background images on your elements. That's only if you want to do rounded corners or something. And we actually have better properties for that now. Border radius is there. So you don't really have to do the weird CSS thing anyway. Also, a word of warning. In this session, you will be hearing a lot about automated techniques for improving performance. And I think that's helpful. That's why we're doing it. We're doing it too at Opera. But there's limits to how far you can go with that. You still had to take responsibility for your HTML code, for your CSS code, and for your images. We can only get so far with automated techniques. So we still need bright minds out there to do the coding. Given that we do want automated techniques, though, I'd like to present Opera's views on those. And we start sort of in the other end. We start not on the server end. We start with the clients, with the users. And probably the product that many of you know, we have about 100 million people using Opera Mini these days, active users. Opera Mini is a small client, originally written in Java, that runs in handsets, typically in mobile phones, many of them in the developing world. And they give internet access, web access to ordinary phones, to ordinary people, people who don't have PCs, perhaps, people who don't have even the power to run a PC. And by what we do there is that we in the fixed network, in the proxy servers, we fetch the pages. You basically just get the URL from the mobile phone. We fetch the page, we compress it to a binary format that we send then over the wireless network to the handset. And currently, we process about 60 billion pages per month on this. We have many people in many places far away from here, like Russia, Indonesia, India, places where the bandwidth costs, you pay per kilobyte perhaps, or there's limited connectivity. Of course, there's never limited connectivity like here, is there? The other thing we do in this space is Opera Turbo. Opera Turbo is sort of similar. It's also a proxy service that compresses. But unlike Opera Mini, which compresses into a binary format, Opera Turbo just compresses by compressing the HTML, the CSS, and the images, much like you talked about earlier here. Opera Turbo is available from the normal Opera desktop application. So if you download Opera from opera.com, you can turn on Turbo. If Opera detects that you're on a slow network, it will suggest, perhaps you should turn me on. And currently, we have about 5 billion page views per month for Opera Turbo. So it's significantly smaller than Opera Mini, which has 60, but still a lot of people are using this. And about a month ago, we introduced WebP into Opera Turbo. We found that, after doing some research, that WebP was the perfect fit to encode the images for Opera Turbo. Here's a typical page. You save about 50% of the bandwidth. It'd be interesting to see how much Opera Turbo can compress on top of the PageSpeed module that we saw there, whether those two will actually, will you double the performance, or whether they equal. We should look into that. But this is typical numbers that we see, that you reduce the size by 50%, and of course then the time also goes down. So images is an important part of this, and WebP we found out was a perfect match. If we take just a sample image found on Flickr, when we do the really hard compression here, when we try to go really low, we see that JPEG has significant artifacts. It may be hard to see in this projected mode here, but you can see in the middle where JPEG is used, we go down from 155K to 8K. We see significant artifacts around the head of the turtle, for example, whereas in WebP, which is even lower, it's down to only 5 kilobytes. We don't see those artifacts. Now, this may be slightly unfair to JPEG because the original comes across as a JPEG from the first place, right? So when you do another JPEG, it seems like you get really weird block effects when these things double up. And that may be one reason why WebP is performing so well. But so be it. You know, it works well, gives us better compression. Here's another one. Again, we see that we have weird, we have strong artifacts in the middle image, whereas WebP gives us better looking pages. Now here's a colleague of mine, Charles. He's a chief standards officer at Opera, and also I think the WebP looks the best here. If you look at the one to the right, you see his wrinkles there. They kind of disappeared. So, you know, if you want to look beautiful on screen, perhaps WebP is the image format to use. Is this something you put into the encoder? Okay. Very good. Now, the uses of WebP that we've seen both in the Apache module and in Opera Turbo, that's where things are being applied automatically. I think there's still a time to go before you can start actually putting WebP images on the web in your pages. Because if you do so, it's going to be disruptive, because most browsers will not be able to see those images yet. If you use Opera or if you use Chrome, and you can go to the gallery and it shows up, but most other browsers will not be able to show that. So there will be a time, and we had the same thing happen when we introduced Ping some years ago. It takes a while before browsers catch up. I hope the other browsers will catch up and add support for WebP, just like they should all support WebM as well. But until they do, you shouldn't really exclude users by relying on this being available. I still think we need to test, we need to make sure, as a web community, we need to make sure that our web pages work in most browsers and most devices. And I think that's also an encouragement to Google. I had to admit that Opera, we have some problem with some of the more experimentative Google services that come out. You're not always good at testing in all cases. So I encourage testing to every one of us. We need to make this web thing work. We can't make it work for half the people, half the browsers. We need to make it work for everything. That's one of the strengths of the web, and I hope that will continue. Thank you.
So we have time for questions, if you have any questions. OK, go ahead. Oh,
Can you come to the
there are microphones in the back.
Please come to the microphone for the benefit of the video.
Okay, so question for Joshua, actually. Two things. We're using Rackspace Cloud, and we pay on a compute cycle basis. How would using Mod Pagespeed affect compute cycle usage? And also, when you're doing combined requests off of a CDN, would that affect when you have multiple CDNs serving the same content and you append them for your CSS requests, for instance, would there be a performance gain loss?
So the first question is about the compute cost associated with Mod Pagespeed. And I should point out that Mod Pagespeed uses a lot of caching internally. So although we are doing image compression and image resizing, et cetera, that's really the only compute-intensive thing we do. But we cache the results, so we only do that once. So, so we think that amortized over your entire site, it will not be measurable, but also please also take into account if you pay for bandwidth, or requests, you'll be serving a lot less bytes and a lot less requests with Mod Pagespeed. Your second question is about combining resources in CDNs, and we support CDNs. We support multi-server configurations. I'm not sure I entirely understand your question. Mod PageSpeed benefits CDNs by making more resources cacheable at the edge. So it's in general a win, and we enable this because if you remember on the combined CSS slide, the link name for the combined CSS file encodes all the information you need to reproduce the result, which is why multi-server is not a problem. I hope that answers your question.
Go ahead.
Howdy. So one of the big reasons that Ping was so able to displace GIF in many fields is that it was not patent encumbered. And VP8 has, among other things, not exactly been forthcoming with complete documentation for the format as is available for JPEG and Ping. And also the guarantee of not being patent encumbered is still a little bit shaky to the point where VP8 simply isn't available in distros that value freedom, Fedora, for example. So while I appreciate the attempt to displace JPEG, now that JPEG is actually patent-free, the patents expired 4 or 5 years ago, how is the WebP team planning on addressing patent concerns?
So I'm not a lawyer, so and I won't be talking about patent, but you're welcome to talk to our lawyers about patent issues. With respect to documentation, I'll give you that. We all sorely lack on documentation. We try our hardest, but at some point we don't have enough. It would be great if you can contribute documentation.
I don't understand VP8 because there's no VP8 documentation available for me to understand it from.
So we've been doing a lot of work on documentation. So we have updated a lot of documentation on VP8, and I can certainly point you to the people that are working on the VP8 documentation. If there's any specific feedback, we can definitely make sure that we cover it.
Are there plans to submit a formal specification in the manner of Ping to relevant working groups for review?
So I'm not the product manager for VP8, so I don't know exactly. I know we've submitted an informational RFC to document what we do. I don't know of the other, the forward plans.
All right, thank you.
Yeah.
So does Mod PageSpeed concept change the way we should approach design? Should I have my designers now producing all the pages and putting the original art in high quality, large size, and breaking up the JavaScripts, making no effort to do manual optimization, because then the machine optimizers could do a much better job with that?
Please don't. I'll start with that. We've seen a lot of HTML files that lie to us, and for many reasons we can't optimize them. When somebody tells us what MIME type that file is, for example, and it's actually the wrong MIME type. That's one of the examples. The importance of Mod PageSpeed is that in many cases, you don't have the cycles to actually redo all the designs. For example, every time you change your UI design, your UI layout, you don't want to go and make every image change. And you want to be careful about the use of your engineers and front-end engineers for that. And I'll let Josh answer as well.
Sure. I don't think that there's a need to make a complete 180-degree turn in how you do your design of your web pages, but it offers you the opportunity to gradually consider maintainability and efficiency of your design process, and let machines take care of the processing. So you could get there, but as always, I would recommend taking it one step at a time.
This may be a silly question, it may be enabled already, but you're speaking of getting Mod PageSpeed enabled on different hosts and different servers and kind of getting it built into different stacks. And it seems to me that Google is perfectly poised to do this, considering it has its own stack in Google App Engine. Is Mod PageSpeed available for App Engine, and is it going to be available for App Engine? It doesn't even apply to App Engine?
It is, I think, the third bug that's open on our issues list today. For App Engine, it is currently not enabled in App Engine. We've talked to the team. They're excited. We're excited about potentially providing it, but we have we have not done any immediate work on this. We want to first focus on stabilizing the technology, making sure that we get the best out of it, and then deployments with other browser servers as well. One of the big questions as well was how about Nginx? How about Apache on Windows? How about this? Like right now we're focused on the core technology, and we look at other things in the future.
Thank you.
I think you actually just answered my question. We have seen a lot of success with Nginx as a front end in front of Apache acting as a reverse proxy, and it would be really great to implement some of these techniques on that level instead. Yes. So that's something that is on the roadmap at some point, or?
I think Nginx in front of Mod Pagespeed, in front of Apache, we've seen Apache with Mod Pagespeed. I'm sorry, we've seen deployments where Nginx is a front end and Apache with Mod Pagespeed enabled is the back end, and that should work great.
Okay. Yeah, thank you.
Can you talk to the applicability of Mod Pagespeed and WebP or similar tools to smartphones and tablets today or in the future?
For Mod Pagespeed, every time you browse a page, you're going to see a faster experience. One of the really cool things about Mod Pagespeed is that it reduces the number of round trips you make, and the round trip on a mobile device is a couple of seconds at some point. So it's very helpful for a wireless and 3G and 4G browsing experience.
Yeah, I'll add that. Mobile best practices are different than desktop best practices in terms of delivering the best web experience. And one of the things that we get the opportunity to do in Mod Pagespeed is deliver an experience customized to the user agent, because we have a fairly a stack that we pay a lot of attention to on a daily basis that gets to see the user agent and then decide what to do. So for example, today we do image inlining only on browsers that we know to support it. And so the image inlining is kind of automatic and it works. It doesn't leave anybody behind. That's kind of also the vision with WebP, is that we could transcode to WebP for browsers that don't yet support it, but for browsers that do, you would get WebP automatically for free without having to. So along those same lines, being able to have kind of a server-side decision about how to render the web page is only going to benefit mobile. Have we gotten everything that we want out of the mobile experience out of Mod Pagespeed yet? No, we're still working on that.
Hi. I work in an organization I think has a fairly typical workflow in that we have a centrally hosted content management system which writes out static assets to a CDN. So, we don't have control over the build out of the technology at the CDN, but we would like to, for static assets such as CSS and JS files, we run a manual compression script before pushing out. For images, however, we don't, have that. We don't have anything in place, essentially. Are there standalone components? Are there ways of ripping out the image compression components of this and running that against our assets before we push to CDN, or are we sort of?
So I guess that the point of Mod Pagespeed is not that we have new or unique image processing capabilities. Under the hood, we actually use OpenCV. ImageMagick is another good engine that a lot of people use when they're doing this kind of manual compression step. The point of Mod Pagespeed is to save you the effort of having to manage that flow yourself. But given that you have that flow and you want to keep doing it, something like ImageMagick or other tools like that are probably the best bet for doing standalone image compression.
But I think you're talking about further out where you have the HTML content and you want to figure out like how the image should be optimized for that HTML content.
Yeah, I mean, there's a number of touch points. I mean,
Yeah.
There's always, especially in fairly large, sites where you could optimize at the CDN. You can optimize before you push to the CDN. You could do some smart edge level page caching, and we've always taken a very simple approach of like compress everything, pull out all the white space, pull out all the comments, compress the graphics as much as we can prior to pushing out to the CDN and not eliminate steps. And so I've seen things like Yahoo Smush It, where you can upload a bunch of images, they come back looking exactly the same, but they're much smaller. And what I would love is an API that we upload an image, we send the image to the API comes back with an optimized, lossless, version of that image, and then we push it to the CDN, if you're into custom development.
So we actually have something that's on the PageSpeed Online API part, which allows you to do, which allows you to score the page against the PageSpeed rules. We currently again give you back results and tell you what you could have done better. That's an interesting request that we'll take into consideration. Because, yeah.
Thanks.
Hi. You mentioned that the time to first byte when using Mod Pagespeed is slightly increased because of the processing it does in some of the optimizations it applies. Could some of that stuff be done offline in a pre-processing step, say before I deploy my resources?
That's a great question. Of course, all of those things could be done, but they have not yet been done. But for the majority of websites, we've taken kind of a conservative approach to HTML and assumed that it's fairly dynamic and typically often personalized to the user, so that caching HTML on the server side is something that would not be kind of our default behavior. However, on the resource optimization side, we already do that because we cache any rewritten resource. So when I talked about that overhead or the time to first byte, that's generally from the HTML, just from the, running it through the HTML filter, because we don't cache the HTML, but we cache all of the rewritten images and CSS files. We don't have to redo those every time.
Thank you.
Thank you all for coming. And I think a lot of people are going to break for lunch now. So we're keeping you away from your food. So please go ahead.
Okay, thanks.